Dear students, we can do the problems in Unit 4, Gravitation and Satellites. The first one is calculate the acceleration due to gravity on the surface of Earth if the universal gravitational constant capital G is equal to 6.67 into 10 raised to negative 11 SI units. Radius of the Earth R is equal to 6,350 km and the mass of the Earth capital M is equal to 5.9 into 10 raised to 24 kg. Here we are asked to find the acceleration due to gravity. So what is the formula? The formula is small g is equal to capital Gm divided by r square. Here we have capital G is equal to 6.67 into 10 raised to negative 11 SI unit. Radius of the Earth capital R is equal to 6,300. The radius of the Earth is equal to 6,350 kilometer. That we have to convert into meter. That is 6,350 into 10 raised to 3. That is also we can write 6.35 into 10 raised to 6 meter. And capital M, the mass of the Earth, that is equal to 5.9 into 10 raised to 24 kilogram. So let us substitute all these values. Then small g is equal to small g is equal to small g is equal to capital G, that is 6.67 into 10 raised to negative 11. The mass of the Earth 5.9 into 10 raised to 24 kilogram divided by the radius square, that is 6.35 into 10 raised to 6 whole square. So after the calculation, you will get the value of G on the surface of the Earth is equal to 9.76 meter per second square. The second question, determine the universal gravitational constant if the force of attraction between two masses, each of 3000 kg, separated by a distance of 20 cm, is 15 into 10 raised to negative 3 Newton. Here we can use the Newton's law of gravitation. Here the formula for the force of attraction between the two masses is F is equal to capital G into small m1 m2 divided by d square. We know the value of capital G. Now here we have to find the value of capital G. And we are given m1 and m2, that is 3000 kilogram, and they are separated by a distance d, that is 2 centimeter, that is equal to 0.2 meter, and the force of attraction between them is 15 into 10 raised to negative 3 Newton. So since we have to find the value of capital G, then from the formula capital G is equal to Ft square divided by m1 into m2. Let us substitute all these values. That is 15 into 10 raised to negative 3. D, that is 0.2. So d square 0.2 whole square divided by 3000 into 3000. So after the calculation, you will get the value of capital G is equal to 6.67 into 10 raised to negative 11. The unit is the Newton meter square per kilogram square. Now we have the third problem. An artificial satellite revolves around the Earth at a height 100 km above the surface of Earth. Find the orbital velocity. Find the orbital velocity. We know the equation for the orbital velocity. V is equal to R into square root of G divided by small g divided by R plus H. Now what is the value of radius? The radius is given 6400 kilometer. That you get to convert it to meter. That we can write in the previous problem 6.4 into 10 raised to 6 meter. And small g, the value of small g is 9.8 meter per second square. And we have to also find the value of R plus H. That is 6400 kilometer plus 100 kilometer. That is equal to 6500 kilometer. That we can express 6.5 into 10 raised to 6 meter. So we can substitute capital R is equal to 6.4 into 10 raised to 6 into square root of 9.8 divided by R plus H. That is 6.5 into 10 raised to 6. After the calculation, we can have the orbital velocity 7.858 into 10 raised to 3 meter per second. 7.858 into 10 raised to 3 meter per second. Now the fourth one. Calculate the mass of the Earth from the following data. We are given radius of Earth R is equal to 6400 km. Acceleration due to gravity small g is equal to 9.8 meter per second square. Universal gravitational constant capital G is equal to 6.67 into 10 raised to negative 11 Newton meter square per kilogram square. So what is the formula for finding the mass of the Earth? That is, we have the relation small g is equal to capital Gm divided by R square. From that, capital M is equal to small g R square divided by capital G. Okay, we can substitute all the values. That is, g is equal to small g is equal to 9.8 meter per second square. radius, that is 6.4 into 10 raised to 6, that we are already expressed in the previous problem. R square 6.4 into 10 raised to 6 square. The value of capital G is 6.67 into 10 raised to negative 11. Okay, so you can complete the calculation and you will get the mass of the earth 6.02 into 10 raised to 24 kilogram. Then move to the next. An artificial satellite revolves around the earth at a height 6,600 km above the surface of earth. Calculate the period of revolution. Radius of earth is capital R is equal to 6,400 km and the universal gravitational constant capital G is equal to 6.67 into 10 raised to negative 11 Newton meter square per kilogram square. Mass of the earth capital M is equal to 6 into 10 raised to 24 kilogram. So we know the expression for the period of revolution of the satellite, that is capital T is equal to 2 pi into square root of R plus H whole cube divided by capital Gm or small g R square. I think we can use capital G. Here the value of M is given. So we can use this formula, this expression. That is T is equal to 2 pi square root of R plus H whole cube divided by capital Gm. So let us write what are the values are given. Here R is equal to 6,400 kilometer and the height of the satellite, that is 6,600 kilometer. So R plus H is equal to R plus H is equal to 13,000 kilometer, that we can express 13 into 10 raised to 6 meter, and the value of capital G that we know 6.67 into 10 raised to negative 11 Newton meter square per kilogram square. Capital M is equal to 6 into 10 raised to 24 kilogram. So we can make the substitute all these values, that is 2 pi into 2 into 3.14 into square root of what is R plus H, that is 13 into 10 raised to 6 whole cube divided by value of capital 6.67 into 10 raised to negative 11. Mass of the earth, that is 6 into 10 raised to 4. So you can complete the calculation and you will get the period of revolution is 14,714 seconds. This is the period of revolution of that satellite. Next, calculate the average density of Earth from the following data. Radius of Earth, capital R is equal to 6,400 km, small g is equal to 9.8 meter per second square, capital G is equal to 6.67 into 10 raised to negative 11 Newton meter square per kilogram square. Here we can use the formula. We know the density is equal to mass by volume. Okay. So let us denote the density is equal to mass by volume. The mass is given by small g, mass of the earth, small g r square divided by capital G. And the radius, the volume of the earth, that is capital V, is equal to, since it has a shape of sphere, 4 by 3 pi r cube. So density D is equal to small g r square divided by capital G divided by 4 by 3 pi r cube. So here 1 r square can be cancelled out, and the 3 going to be the numerator. So 3g divided by 4 pi capital G r. So what are the informations are given? We are given the value of g, small g, and the capital G, and the radius. So we can make the substitutions. So the density of Earth is equal to 3 into 9.8 divided by 4 into 3.14 into capital G, 6.67 into 10 raised to negative 11 into the radius, 6.4 into 10 raised to 6 meter. So after the calculation, you can find the average value of density is 5483 kilogram per meter cube. The seventh one. A remote sensing satellite of Earth revolves in an orbit at a height 300 km above the Earth's surface. What is its orbital speed and period of revolution? We are given the radius of Earth is equal to 6400 km and the acceleration due to gravity small g is equal to 9.8 meter per second square. So we have to use the formulas for the orbital velocity and the period of revolution. So first we can write the value of the radius. We can express 6,400 kilometer, that is equal to 6.4 into 10 raised to 6 meter, and also we are given the value of small g, that is 9.8 meter per second square. So the orbital velocity small v is equal to r into square root of g divided by r plus h. So what is the value of r plus h? R plus h is equal to 6,583 6,700 kilometer. That is equal to 6.7 into 10 raised to 6 meter. Okay. So let us substitute the values. 6.4 radius 6.4 into 10 raised to 6 into square root of 9.8 divided by r plus h is 6.7 into 10 raised to 6. So after the calculation, we can have 7,740 meter per second. And also we can express 7.74 kilometer per second. Now the period of revolution. We have the formula. Capital T is equal to 2 pi into square root of r plus h whole cube divided by small g r square. So let us substitute 2 into 3.14 into square root of r plus h is 6.7 into 10 raised to 6 whole cube divided by 9.8 into 6.4 into 10 raised to 6 whole square. That is a gr square. So after the calculation, you will get the period of revolution is 5,436 seconds. The next problem. Two spheres, each of mass 7 kg, are 14 cm apart. If the force of attraction between them is 1.6675 into 10 raised to negative 7 Newton, calculate the universal gravitational constant. Here we can use the formula. The force of attraction between the two masses, that is F is equal to capital G into M1 M2 divided by d square. From that, capital G is equal to F into d square divided by M1 into M2. So let us see the value of F. F is equal to 1.6675 into 10 raised to negative 7 Newton, and M1 is equal to M2 is equal to 7 kilogram, and the separation D is equal to 14 centimeter, that is equal to 0.14 meter. So we can substitute F is equal to 1.6675 into 10 raised to negative 7 d square, that is 0.14 whole square divided by 7 kilogram, that is 7 into 7. So after the calculation, you will get the value of capital G 6.67 into 10 raised to negative 11 Newton meter square per kilogram square. Okay, the next one. A satellite revolving around the Earth of radius 6,400 km takes 10 hours to complete one revolution. Find. The first one is the distance to it from the surface of the Earth. Second is its orbital velocity. Here we are given the value of small g. So let us write the value of small g is equal to 9.8 meter per second square, and the radius of the Earth, that is 6,400 kilometer, that is also expressed 6.4 into 10 raised to 6 meter, and the period of revolution, that is capital T, is equal to 10 hours, that we have to express in seconds, that is 10 into 24 into 60 into 60. And let us see what is the expression for the period. We know the period T is equal to 2 pi into square root of r plus h whole cube divided by g r square, small g r square. From that, so there is a correction in the value of the time period. That is only, we need to take only 10 hours, that is 10 into 60 into 60. So that is equal to 3000, that is 36,000 second. And we have here, from this equation, we have to find out the value of h. So let us square on both sides. T square equal to 4 pi square r plus h whole cube divided by gr square. So r plus h whole cube is equal to t square into gr square by 4 pi square. So what is r plus h? Taking the cube root on both sides. T square gr square divided by 4 pi square raised to 1 by 3. Therefore, what is the value of h? H is equal to t square gr square divided by 4 pi square all raised to 1 by 3 minus capital R. So we can substitute all these values. T is equal to 36,000 square, 9.8, radius is 6.4 into 10 raised to 6, that is also square, divided by 4 into 3.14 square, whole cube all raised to 1 by 3 minus value of capital R, that is 6.4 into 10 raised to 6. So after the calculation, you can find the value of the h is 17,228 kilometer. 228 kilometer. And the orbital velocity v is equal to 2 pi into r plus h, that is the circumference by the time period, that is equal to the distance by time that is 2 into 3.14 into here r plus h, that is 6.4 into 10 raised to 6 plus h is equal to 17.228 into 10 raised to 6 all divided by the time period is 36,000 seconds. So after the calculation, you will get the value of orbital velocity is 4,120 meter per second. That also we can express 4.12 kilometer per second. Okay. The next one. Find the acceleration due to gravity at a height 50 km above the earth and at a depth 100 km below the surface. The radius of earth is capital R, that is 6,400 km, and small g at the surface is 9.8 meter per second square. Here we have the values. The radius of the earth, that is capital R, is equal to 6,400 km, that is also equal to 6.4 into 10 raised to 6 meter, and the value of g on the surface of the earth is 9.8 meter per second square, and we have to find the value of g at a height h is equal to 50 km and at a depth d is equal to 100 km. That we can also convert into meter, that is 50 into h is equal to 50 into 10 raised to 3 meter, and d is equal to, that is 100 kilometer, that is 10 raised to 5 meter, that is 100 into 10 raised to 3, that is equal to 10 raised to 5 meter. Okay, now we know the variation of g with the height. We have the expression for the value of g at a given height is given by gh is equal to g into 1 minus 2h by r. So let us substitute g on the surface, that is 9.8, 1 into 1 minus 2 into h is equal to 50 into 10 raised to 3 divided by the radius is 6.4 into 10 raised to 6. So after the calculation, you will get the value of g at the given height of 50 km is 9.647 meter per second square. Now let us find the value of g at a given depth 100 km. So at a given depth, the value of g is given, gd is equal to g into 1 minus d by r. Again substitute, that is g 9.8 into 1 minus d is equal to 100 km, that is 10 raised to 5 divided by the radius 6.4 into 10 raised to 6. So you can see, you can also compare these values in the values for the value of gh. So from that you can easily find out the value of g is again is equal to 9.647 meter per second square at a given depth 100 kilometer. So at a height 50 kilometer and at a depth 100 kilometer from the surface of the earth, the G has the same value. Next one, if the mass and radius of the moon are 7.6 into 10 raised to 22 kilogram and 1740 kilometer respectively, calculate the acceleration due to gravity at the surface. So we have the formula. The expression for small g is equal to capital G m divided by r square. Here the value of capital G is equal to 6.67 into 10 raised to negative 11 Newton meter square per kilogram square, and the mass of the moon capital M is equal to 7.6 into 10 raised to 22 kilogram, and the radius of the moon is equal to 1740 kilometer, that we can express 1.74 into 10 raised to 6 meter. So let us substitute 6.67 into 10 raised to negative 11. Mass is 7.6 into 10 raised to 22 kilogram divided by 1.74 into 10 raised to 6 square. So after the calculation, you can find the value of small g, that is acceleration due to gravity, on the surface of the earth is, on the surface of the moon is 1.67 meter per second square. You can just compare this value with the value with 9.8 meter per second square on the surface of the earth.